Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad YUSRA bin Sri with the numbermetry of AA 2009-34. Today, we are from the Group 5, Section 1. We'll present about our engineering designs group project, which the title is Keropok Leko Extruding Machine. As you can see, the following is the member of the group. The first is Mohamad Zulfakar. The second is me, Mohamad YUSRA, and the third is Mohamad ERFAN. So, our presentation begins by me discussing our first chapter, which is introduction. The main objective of our group project is shown as below. The first is to identify the problems found in the production of keropok lekor that face small businessmen. To specifically design the keropok lekor's extruding machine along with new innovations to create the prototype of keropok lekor's extruding machine. This chapter also contains the project scope that targeted to achieve our project goal. First is, this keropok lekor's extruding machine has a hopper or space where possible loading capacity of large dough. Therefore, this machine is capable of accommodating a dough capacity of 10 kg. This keropok lekor's extruding machine is versatile in the scope of dough quantity to be used, but not to exceed the capacity limit that already set. Therefore, this machine can produce keropok lekor in the same amount depending on what is required. This keropok lekor's extruding machine is also only in medium size. This machine is easy to operate and can be conducted by 2 or 3 people. So the next sub-chapter is significant study. The study was conducted to know how innovations in keropok lekor's extruding machine that will impact and benefit to the keropok lekor's businessmen. Through this project also will help the businessmen to get better machine with better efficiency at a reasonable price. I will pass the presentation to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AMIRUL bin Mohamad ROSDI. Nombor metrik AA 200326. For the chapter 2, identification of need. For the table 2.1, product design specification for keropok lekor extruder machine. The title is keropok lekor extruder machine. For the introduction, design problem. Due to the keropok lekor, the dough stuck at the wall of the barrel that will affect the machine performance and can make the machine broken. Intended purpose to make the dough came out in cylinder shape. In unintended purpose can make the nozzle clog with the dough. For the special feature, the machine can make the dough have the same quantity, and the consumer can choose the diameter of the keropok lekor based on the diameter of the nozzle. Customer requirement. Functional performance can carry up to 10 kg dough in one use. Can change the diameter of the keropok lekor. For the operating environment, at flat surface of the floor. Ergonomy. The machine should have ergonomic life more than 2 years. Geometric limitation. The size desirable approximately 200 millimeters wide, 1094 millimeter long, and 350 millimeter tall. Maintenance, repair and retirement. The repair should be retired at least one time a year, and the cleaning should be easy because of the material they are used. For the safety, there are no sharp edge and screw part are hidden. human factor. There are no large stock that the person need to apply because it is automatic. Pollution, there are no carbon emission because using electric power. For the constraint 1 should not be used near water source. Constraint 2, the machine are flexible and can be damaged with outside force. Customer certification, which one? Fully automatic to shape the dough. For the chapter 3, background of studies. Basically, keropok leko was created or processed using only energy and without the help of the modern tool. As we know, there are several ways to produce keropok leko, such as grinding the raw fish filling using the blender and mixing a little flavor like salt. The next method is continue by mixing the flour and ending it by kneading and then boiling it. This process is estimated to take 3 to 4 hours without modern tool processing. As the market for keropok leko in the past increased rapidly, this was given attention by the local engineer to produce a dough kneading machine. Or fish fillet with flour that has been mixed, or also known as a vertical dough kneading machine. Recognizing with the physical energy to knead a dough that may have a capacity of 10 of kilogram. This is something that is right as a start for the development of cracker machine technology. The technological development of the keropok leko machine does not stop at the dough kneading machine alone. This is because the dough kneading machine is only able to solve one method of making keropok leko only, and the average local people prefer to knead the dough traditionally because they want to ensure that the amount of starch and fish filling is mixed evenly. With this method, the production time is very long, and they cannot produce in large quantities because of the energy that they spread to the shape of the keropok leko. That's all from me. Thank you.
That is conceptual design. This chapter begins by introducing one method for constructing a block diagram of the product sub-assemblies, which is product component decomposition. The product component decomposition generated to show all the processes and to identify relationships and dependencies among the components. Basically, the keropok leko's extruding machine have 6 main components. That components are body, motor, hopper, bearing, nozzle, and extruder. Next, I will discuss about the product concept development. Morphological metric is generated to create ideas and explain the each subfunction of product component decomposition about keropok leko extruding machine. As you can see at the table shown, there are 4 components selected that has been divided into 2 parts of 2 types. Move to the table 2, which explain us about the alternative design concepts. Then, I will talk about alternative concept evaluation and selection. After a large number of concepts have been created, the most appropriate concept must be chosen to meet the product design specifications requirement. As you can see at the first sketch, that is using the concept of sausage making machine. Second and third sketch that using same concept with roller concept. I will pass our presentation to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Zulfakar bin Mohamad Rizal. My number matrix is AA200477. So I will continue the presentation in chapter 5. So chapter 5 is on embodiment design. So for the product architecture, there are two sections. First is modular and then integral. So in the slide, I show the modular and also integral for the component and also the functional element. Next is design configuration. So for design configuration, we use the weighted rating. So for the high efficiency, for the extruder concept, we rating for 5. So the weight rating is 1.5. High reliability is 5. So extruder 1.25. Low maintenance is 0.6. Low cost is 0.45. Low weight 0.2, and the total of the rating is 3.85. Next is rolling concept. So the rating for rolling concept for high efficiency is 5, so 1.5. High reliability is 4, 1.0. Low maintenance is 3, 0.6. Low cost is 2, 0.3. And lastly, low weight 2, 0.2. So the total is 3.75. So for the design configuration, we know that extruder concept is more suitable than rolling concept. Next is parametric design. For parametric design, we show the full assembly for our machine and also the explode view. We also show the rough dimension. Next, for analytic design analysis. For this, for every shaft or thread, diameter is 120 millimeter for diameter of the screw, and diameter of the shaft is 60 meters. So we put in the formula. So we get 0.008483 meter per square. And next, for the chapter 6 is the final design. For the final design, we show the 4 drawing. First, assembly, screw parts, front cover motor parts, and also the barrel part. Next, we go to manufacturing process. So manufacturing process for fabrication, welding and cutting, the subcomponent that are chosen is barrel, screw, barrel leg, hooper, and also nozzle. So for the base type material, for the barrel is we use the stainless steel pipe, screw we use stainless steel round bar and also stainless steel plate. Barrel, hooper, and nozzle choose the same type of material, stainless steel plate. So the fabrication barrel are using cutting and machining. Other than that, using cutting, machining, and also the welding. For assembly, is non-permanent joint, bearing, motor, and nut and bolt. So bearing and motor have same base type material, steel, and nut and bolt are using the stainless steel. So we can buy online and also buy at the hardware. And then for last of the chapter 6 is cost prototype. All the quantity are the same, one other than nut and bolt. So for the material for the motor, we use steel. The cost is around 350 ringgit. Copper type 304 stainless steel, 80 ringgit. Nozzle 60 ringgit. Nut and bolt 20 ringgit. Screw extruder 100 ringgit. Barrel 100 ringgit. And lastly, ball bearing using steel 30 ringgit. So the total price of our prototype is 740 ringgit. And lastly, chapter 7 conclusion. So what can we conclude is this mission is designed to achieve the general objective and to make its goal come true. And lastly, with the guarantee of many benefit and interest that will be obtained, then the creation of this corporate Lego machine product is able to overcome the problem faced by small entrepreneur. So that's all from our team. Thank you very much for listening.